Hello. Uh, Welcome. We're going to talk about recursion, and I'm sure some of you have had me before, have had me talk about recursion before. My favorite example is to use the asterisk diamond uh, assignment. But what I want to do is show you the mechanics of recursion first and what I refer to as winding and unwinding the stack. So, what is the stack? Well, the stack is memory that's given to your process, and this process is the common runtime process of Java that's interpreting your code. It's the automatic memory that's given to that process itself. And of course, you're creating a process. You're creating instructions to be performed by the interpreter. Interpreter is a loose term. It's not really, but so the stack kind of comes all together with things like scope and most importantly function calls, and that's pretty much where it lives. And you can use it for a lot of slick math stuff. uh, there's even slick ways to solve problems using recursion. But here's the thing is, in like industrial environment, recursion is mostly not used because of the problem that it has being able to blow your stack. And that's when you call the function, or call any set of functions that create or ask for automatic memory beyond what has been given to your process automatically. And the stack is that automatic memory. And that's why we call them auto variables, in the debugger. And how the stack behaves is how recursion happens. So let's just talk about programming and a stack. And I'm going to be using a simple example. We're going to throw it through the debugger, and we're going to talk about that winding the stack and unwinding a stack. Let's just start with some simple functions that are arbitrary. We will just call one public void function 1. And we will have a few others in there because I'm going to demonstrate what actually is happening with winding the stack and unwinding the stack. Function 2. Actually, you know what? Let's do this because I want to do proper top down. So that will be 2, and then this one would be 1, and each one's going to call each other. And then and basically what I'm demonstrating is how the stack behaves. We will discuss it, what it is, what happens, probably right now. Actually, that's a good idea. Let's go ahead and we're gonna do some scribbles. I know. I feel your pain. Actually, I do. Okay, come on. Where are you? There we go. Hopefully it works okay this time. It looks like it's doing okay. All right, so when a function is called, and let's just use, for instance, and what I'm going to do is I'm going to kind of point to here, and let's just fill this out a little bit. But when a function is called, such as main goes on the stack. So main, the function itself and all its instructions goes on the stack. And inside of main, we would have variables that also go on the stack. Now, those will be variables that are only at main scope, but they're still on the stack. And let me give you an example. And a simple one, just declaring an IJ. All right, let's do that. And then what we're going to do is we're going to call function 1. My keyboard's being silly because I got the whiteboard out. There we go. All right, we would call function 1. And so what happens when your runtime comes in is it hits this line. And this is after main has gone on the stack. It hits that line. And I goes on the stack as well, within the scope of main. So I'm going to put it right here. I. And that's set to 4. Then function 1 is called. And all of function 1 and its instructions goes on the stack. Now, since this is also calling a different scope, I'm going to show that when I put the variables in here, because function 1 gets called. Main is still on the stack. It's still running. The main function is still running. And this is like, well, this is stuff that that happens with functions. They go in, they run, and they come back. That's winding the stack and unwinding the stack. When you go into a function, you're winding the stack up. That means you're putting more items on the stack. And for the program to end, the stack must unwind, or the executable will fail. And that's when it comes back to its main calling point. So in this case, we just call function 1. It doesn't do anything. It continues on, comes back from function 1 call, creates a double, and then goes on from there. But function 1 gets called, and let's do this. We're going to have an integer called k equals to 4. And what we're going to do is we're going to grab this guy right here. And we're going to put hello world. We're going to put F1 entry. Then we're going to do this. Int y. And this is going to call function 2. Then after function 2, let's just do another print. We are going to put F1 exit. Then we're going to do the same thing in function 1, except for we're going to call this different. It doesn't really matter. In this case, F2 entry. Oh yeah, we're gonna call it F3. You know what? I'm going to keep these variables the same because it doesn't matter. They're all in their own scope on the stack. Okay, so I'm calling function 3 here, winding the stack still. And I'm going to call this F2 exit. Then what I'm going to do is I'm going to copy it again. But actually, no, we're not going to have any more recursive calls. We're just going to do something like this. Actually, yeah, let's grab the whole thing. And we'll modify it appropriately. F3 entry, F3 exit. Okay. Currently, we're at function 1 call. When the runtime comes into here, K goes on the stack. Because, I'm talking about when the program first runs from main, I goes on, main and the whole function goes on the stack. Then I is created. Then function 1 is called. So function 1 and all its instructions and everything about it goes on the stack. And then when we get into the inner parts of function 1, its automatic variables, locals, will go on the stack. So then your runtime control will get to this line, K is equal to 3. And so K at 3 goes on the stack. Oh my goodness, my scribbles are already getting nuts. K at 3. K is equal to 3. Okay, that's good enough. That goes on the stack. Then function 2 goes called and everything about it. You're like, oh, Mr. B, I know all this. Yeah, but you can use this behavior and the idea of, using the stack and function calls to traverse data is kind of the idea. So this is function, we're right here. Oh, yeah, it calls function 3. So function 3 goes on the stack. Okay. Oh, excuse me, I wrote my code wrong from what I'm talking about. Oh, that's right, I just did this. I forgot to finish this out. And we're not going to do anything here. We're just going to say entry exit. All right, now function 3 gets called. What we have on the stack is main I function 1, K function 3. We haven't even gotten to, like, for instance, the call for function 2 on line 29. Our runtime hasn't gone there. So that stuff's not on the stack. The function call is, and then we got to complete the function call, throw all that stuff on the stack, including the instructions in the function. And then we're tunneling a hole of logic with our runtime. So we get to function 3, and function 3 just kind of gives us some output, and it gets done running. So right now our control has started here, gone to here, to here, to here, and I'm talking about our runtime. So now our runtime is here. Function 3 gets done running. The runtime has gone down into here, and what does it do? It comes back to line 28 with the function 3 call. So our control then comes back to line 28. Function 3 is done being called. K is still on the stack. We're now in this runtime scope. So not only is there runtime and scope, but there's runtime scope. And that's recursion, is using that mechanism. So now I come back here. Did I even put R? This was R. Oh my goodness. R is equal to 3. It comes back. R is still on the stack. Y goes on the stack. So then Y goes on the stack. And then it unwinds back to here. The calling point right here on the stack. So when the function 3 gets done running, it just cascades back. And this is the unwinding. And then it visits all these lines right here. All these lines that aren't on the stack yet. All right. I know I missed some stuff on the explanation. I think I skipped ahead on a few things. So we're going to actually run through it with the debugger, so it keeps me on track with what's going on. And it's going to get messy. I can tell you that right now. It's going to get messy. Okay. Let's start. I'm going to have to make some room. Let's start in main. Set the bookmark. Here we go. Oh, okay. Maybe not quite yet. Yep, I forgot we're in Java. We're going to create an object that we actually instantiate on the stack first, and then I'll take you through the functions. Yeah, that's one little oversight. I'm going to be doing this a little bit dirty, though. I'm not going to be putting it in another separate file because I want everything to be kind of together so that we can get the whole idea. And then what we're going to do is we're just going to call this recurse as an object, and we'll do it right in the file. Let's see. And then I'm just going to throw in those functions. Okay. No, let's do this right. Java actually won't allow me to do that. I forgot. It happens. Okay, so what we're going to do is we're going to define an object to demonstrate winding and unwinding in the stack with the whiteboard. So let's go ahead and get busy on that. I'm going to go ahead and ask for a new Java class within the project. We're going to call this recurse. Oh, no. Oh, it's already called recurse. It looks like I might have to make a few changes as well. Okay, I'm just going to call it demo. Okay. It looks like I got to rename this. Got to do a little quick refactor. There we go. All right. Now, demo is going to have our functions that we're going to, because I could do it this way, but I don't want to make these statics. I just don't. We don't use statics. Statics are bad. Unless we need to use statics. Okay. There we go. Let's get them into our demo. Let's throw in a constructor. And the constructor will act as our main, a default constructor. That will, we'll just instantiate it, and then this will call our function 1. I think I had something like x equals 3, this dot function 1, and then y equals 2, just, stuff that I'm going to demo with you. And it doesn't matter what order we have these in, I think. Yeah. Okay. Let's finish these up. Looks good. Hopefully we can get into something. Okay. Right now what we're going to do is, this is going to be like, the stack is going to get really messy here, guys. Oh yeah. Okay. Because we're going to instantiate a demo called D. And the constructor will run that, and we're going to trace it through with our nice little whiteboard. Okay, here we go. Let's set a breakpoint for right here, right at the very beginning. And we're going to step through. We're going to debug it. Okay, stack. Here we go. Okay, main gets called. Where's my marker thing? There we go. Okay, so main goes on the stack, the whole thing. Okay, then what is created? A demo called D. Demo called D goes on the stack right here. So when we do a step over, boom, that goes on the stack. Now what I'm going to do is I'm going to trace the stack and its runtime through. So now I'm going to do is I'm going to step into here, and we get into the next call, which is X. So X goes on the stack right here. Then function 1, I'm just going to abbreviate here, F1 gets called into the stack. So X is on the stack, F1's on the stack. Okay, I'm going to step into this one. Now function 1 is being called. K goes on the stack. K goes on the, K. K goes on the stack here. Then F2 gets called. And these are all in their own scope. So that's kind of why I'm slanting it over. Well, maybe I'm not doing a very good job of that. That's okay. So K gets called, then F2. So let's step over. We're moving into F2. Now F2 is called. F2 is called, R goes on the stack. Let's just go straight up now. Heck with it. Okay, then F3 goes onto the stack. F3 is called. Let's step into. You notice how Y hasn't been put on the stack? We haven't gotten there in runtime yet within that scope. Okay, now I'm going to step into. Now F3 is being called. F3 was called. And our runtime has moved through all these function calls, putting all these items on the stack. And what a stack does is it's pretty much first in, first out. And that type of mechanism is very useful with some of your computer algorithms out there. Okay, the F3 call gets done. Nothing goes on the stack. And then notice how it comes back to the function 2 call. So that means what it did is our runtime then finished F3, came back to the location in F2 that it was at when it called F3. So it came back to this line right down here. See our runtime there? So F3 that runtime is off the stack. We still have R on the stack right here, and then we just add Y on the stack. And then what happens? Y is on the stack. F3 is done. We come out of F2's call. Back to F1. So what happens then is Y and R of the previous F2 call. Is your mind going numb now? It makes my mind just kind of crazy sometimes. Recursion. So, yeah. Okay, F2 is done calling. That comes off the stack. Okay, now we come back. And what's on the stack right now after F2 is running? We have K, because our runtime's in function 1 within that scope that has K available. And guess what it does? It puts a Y up there. Right there. Puts a Y. So then we got K, then Y. So that gets done right. Then we're back to the demo call. Okay, we came out of F1. F1 got done running. Now we're in the scope where X lives. And incidentally, we came out of function 1 call. Y goes on the stack. Then we get coming out of the demo function call that's on the stack. And it goes back to its calling point, which was this line in main. So it got done running. Our stack unwound all the way to main. So all this is winding the stack. And coming back is unwinding. And you're like, Mr. B, we've been doing that the whole time. Yes, you have been. But in the frame of recursion, things change. Now remember, if you're doing a lot of data, recursion doesn't make sense. It's more for science. Okay, so main comes back and it gets done running, adds J onto the stack. So now we have J and D. So we have main, we have D and J, and then our runtime comes out, drops all the way back, and it goes back, that control goes back to its calling place, which was from the command line, which called our console program. And therefore, the executable is done running. It's over. So we see here that our outputs, they can kind of, it's when we are tunneling, you see we got F1 entry, entry, entry. Then, so this is winding the stack. And then as we exit, we're unwinding. Okay, now I've shown you winding, in the I've shown you winding in that kind of frame, but let's get into where this can get you into trouble when you're dealing with recursion. Okay, what if we decided we wanted to have function 1 continually call itself? And we're just going to get rid of these guys because they're... Okay, so that means that function 1, instead of calling function 2, it just calls itself. Yeah, and here's the problem that happens. You get an error, because you blow the stack. Stuff goes wrong because you're using too much memory. And I think Java catches it. Yeah, it'll catch it and tell you. Python does the same thing. It catches it when you got a runaway process. But that's what we call Stack Overflow. Now, you might have used that website, stackoverflow.com. That's why it's called Stack Overflow, because when you overflow a stack, you're basically really using the memory that you have locally from what's given to your process. And it's pretty much a common thing that happens usually, you know, when when people are really starting to get their stride and their skills. So now what this does is that it tunnels a hole. It just keeps going. Why? This line is never reached. Never. Now what we have to do is we have to put an if statement in here and tell it when to quit calling itself, because it's just digging that hole. Now one assignment that I use a lot is the asterisk diamond. It gives you the ability to understand that winding and unwinding mechanism and how it's used as an algorithm to solve problems. So let's demo that real quick here, and then you guys can, you know, take it from here with your assignments and whatnot. So yeah, this is going to be a program that calls a function and sends it how many diamonds it wants to print, or how many asterisks. So essentially we want it, the first line to print 1 asterisk, second line to print 2 asterisks, the third line to print 3 asterisks, and so forth in a diamond pattern. And then it should, after it gets to the amount of asterisks you initially want to print, like say you put 6, after it gets to printing 6 asterisks, it starts going down to 5, then 4, then 3, then 2, and 1. And both ends, that when you print the top of the diamond, that's where you're winding the stack. But then you can use that other part where you're coming back from your recursive calls. And so this would print something like this. And I'm going to throw this in here as kind of a comment block. And what the expected output initially. If we put in 3, we would have a 1 star, then output 2 stars, then output 3 stars, then output 2 stars. Oops, I forgot my new line. Then output 2 stars, then output 1 star. Now there's a lot of fence post issues that you would have, and then you would make it so that your output would have spaces in it so that it kind of printed like a diamond pattern. And that's kind of easy to do. You can just put in some spaces for where you need them depending on what line you're on that you're currently outputting information on. And so like for instance, here is 2 spaces and then here is 3 spaces. Here is no spaces, 2 spaces, 3 spaces. You see the pattern? So you can use that local scope to determine how many spaces that need to be printed for this particular row. And what we want to do is we want to send the argument of how big we want the diamond by describing its middle row. And so what that is it's an integer number of stars. Okay, and this is going to be the total number of stars. Oh, I'm doing that in runtime. You know, hey, all right, yeah, whatever. Sometimes it takes me a while to get my Java hat on. Number of starts. Here we're going to say 4 stars. No, odd is easier to start with because you're going to have some offsets and some weird things with getting the proper star pattern to, you know, for a specific line. You're going to have some off by 1 errors that you're going to have to account for. I'm just going to demo it and give you the brief, and then you guys can play with it. So we want 5 stars across in the middle. that's the total amount of stars. But here's one thing that we need. We need, with each recursive call, we need what star we're actually on. And so when we start this, you can start it with 1 or 5, but it's, we want, I like to go 0 base, so I say we're on the 0th star. And those limitations may, depending on how you actually build it, may change. So this is going to be int n, which is the number of star I'm number of the line number I'm currently on. Okay. And then what this is going to do is I'm going to have a print of the asterisk before the function call. We're going to highlight this. We're going to go back on this one. And let's just, while we're digging a tunnel, we're going to have some limitations. And one of those limitations is once we've reached the middle, we're no longer going to recursively call the middle of the diamond pattern. And so I'm going to say if function 1, if n equals, and again, this is going to have, it might be n stars, not minus 1. You're going to, I call that starts, really? Come on. Okay. And right there, that's going to be if n is equal to n stars, we do nothing. So we recurse until then, which is kind of dangerous. So let's do this. Let's flip it and only put it in is no. Insert. Yeah, that's right. Yeah. Okay, fine. We'll do it that way. Back with it. Let's go. N does not equal n stars. That's going to be our call. When n is equal to number of stars, that's when we stop being recursively called. So we're going to say not equals. As long as it's not equals, then we will call the function again recursively. And that's going to be our limit on the recursive calls that this function can call itself. And so we'll keep track of those variables every time. Okay. And then we'll do this. All right. Now what this is going to have to do is each line I'm going to have a certain number of stars I have to print. And so initially I'm going to say for int I equals 0. I is less than n for the number of lines we are on, and then we go until n stars. Oh wait, no, I'm doing this wrong. I is less than n stars. That's, no, n. That's how many we want to print, and then we're going to go n plus plus. Yeah, there we go. That's what I'm wanting. I is less than n and I plus plus. Okay. So if that happens, we're going to print out an asterisk. Now what does this do? Well, let's find out. I'm going to set the breakpoint for right there because we're just treating this like main. Just because, yeah, whatever. Okay, stepping into, the first thing I see is n is 0, therefore we're not printing any stars. Oh, I already see a problem. Each time through this function, we want to iterate n. And again, this is kind of inefficient. We may want to pass 1 here instead. Yeah, let's do it that way. So we print one right off the bat. Then what we have to do is we have to say n plus plus. Because every function call, we want every time that we print that number of lines, we want to iterate n to the next line for the possible next function call. And actually, we should probably put it down here and do plus plus n, so it iterates n first before the function call. So now let's look at how this works. I'm going to actually restart this. All right, step into, we print 1 star. Okay, goody gumdrops. Let's look at our output. There's our 1 star. Now we go in here and n is going to be iterated by 1, and we can put a watch on that, but it's now before it goes into the function, it's going to become 2, and we're now digging a hole into the second function 1 call. Okay, now we're in the second function 1 call. You notice n is 2. So now we're going to print 2 lines. Okay. Now I already see a problem because I printed 2 lines, but I didn't do a new line. So I'm going to have to put in that new line character to put those asterisks out properly. And then we go into the next call, and we're going to go all the way out until we hit that, 5 asterisks in the middle point, and then we're going to stop. So let's do this. What was it that I needed to fix? It was that, new line. Let's just inject it in. Let's inject it in. We're going to put our new line in right there. So it prints the asterisk first. Okay, now when we run this, I'm just going to run it. You see how it kind of comes out? 1, 2, 3, 4, 5. Okay, and then here's what we can do is we can come up with another for loop that we will invert the logic based on what line number it is to print a space. And then print the asterisk or something like that so that we can have our diamond. We will put the leading spaces first. So when n runs, and we need, let's say, 4 spaces in here, we can print that space for, I think it might be n minus n stars. Let's just look at it. That possibly will do the spaces. Oh, duh, it's not going to do anything. Because it should be n stars minus n. Yeah. Okay. Okay, there we go. So you see, it's not quite there, but you see how it's kind of got the verge of the diamond? Okay, then that means that I may need to print a space in between each asterisk to really kind of get it really in. Okay. All right. I'm not going to mess around with this too much more because actually it might be just yeah. Okay. So I'm getting, oh, wow. Cool. Whoop, whoop, whoop. All right. We got it. Yeah. All right. So here's the last thing into kind of what I was trying to describe. When you're using recursion, you're not just solving problems when you're winding the stack. You're also solving problems as the stack unwinds. And if I wanted this then to work the same way as it was coming out of every function call, I can literally just take these 2 lines, and after I take these lines, and after the recursion, when it's coming out and it's unwinding, print the stars again. Done. So it's solving that problem. Okay, yeah, there's issues there with fence posts. If you're doing this, fix those fence posts, because look, it's got quite the middle band there. It's an interesting diamond, but you can see here that we got a fence post. Definitely a fence post in the algorithm. That can be up to you. Oh, and then look at this other fence post. There's not an asterisk down here. All right. I think this was enough for you. This will give you a good head start on thinking, wrapping your head into what recursion is and how it works within, some algorithms. And make sure, guys, seriously, step into it, examine it, and see what's going on. Look at the values of the local stack, because every function call is a new stack, or excuse me, not a new stack. Every function call gets added to the stack. All right. Thank you. Bye.